So this is day one officially. Last week we spent some time, because this is a pilot, making sure everybody really understood how to access their online courses. I believe at this point, everybody is in Visto, has put those courses in their cart. And at this point, you should have at least completed your electrical module. There's 3 components in the electrical module. So if not, or if you're still having issues with that, you need to send me a message and we need to get that sorted today, because you're going to be drastically behind if we don't get you caught up with that, because by tomorrow you need to have the plumbing modules done as well. I sent everyone kind of a 1-pager that gives you some suggested timelines to help you stay caught up. So that should help you make sure that you get all the modules done in the order that you need on time, so that you're really set up. So with that, good morning, Brian.
Good morning. How are you today?
I'm good. We missed you last week, but we were well taken care of. We're glad that you're back. Hope everything went well. And I'm officially volleying it over to you.
Awesome. Well, good morning, everyone. My name is Brian Wilhite. I started as a maintenance technician back in 1997, 74-unit property. I did everything from electrical to painting to mowing of the grounds, trimming of the hedges. I knew nothing about what I was doing at the time. I was 19 years old. I learned my way through it, decided to move to Omaha. And when I came to Omaha, decided to go to school for heating and air conditioning. So I have a degree in heating and air conditioning and currently hold a master's license in HVAC here in Omaha, Nebraska, where I own my own heating and air business. Through the years, though, I've been a maintenance manager, maintenance supervisor, regional maintenance supervisor, head of safety for Selden Company, team trainer for NAAEI back in 2015, and enjoy traveling the country and meeting a ton of maintenance professionals like yourselves and teaching. I'm not the most politically correct. Again, at the end of the day, I'm a maintenance guy. It's what I started with. That's what I am. I've been through on-call. I've done all the things that a lot of guys that have been in this course before have gone through. So if you have any questions, excuse me, I don't know the answers to all of them, but if I don't, I know somebody who can. I don't claim to know everything about everything. So if you need to talk some things through, we can. Today, we're going to talk about electrical maintenance and repair. Start from the beginning and go through it. I'd like to have you guys introduce yourselves to me, saying this is my first time with you. Tell me a little bit about yourself, how long you've been in the industry, what your position is currently, and what you're looking to take away from this course. So I know this is kind of crazy because we've got a whole slew of you here. So let's start with, let's see, Nick Abernathy. Start and kind of work our way around here.
Good morning, Brian. I've been in the industry for about 18 years now. I'm the portfolio maintenance director for Epic Asset Management. And I'm hoping to take away more so knowing what my associates are learning in these classes and become certified for. So,
okay. Gary?
Good morning. My name is Gary Buckin. I work for Epic Asset Management as a supervisor. Just hoping to take away more knowledge and learn more today and throughout this course.
Gary, what's your strong suit in maintenance?
Leadership.
And your weak? What'd you say is your weak point? Like for me, drywall. I can tell you I'm not a really drywaller.
I'm not a huge plumber, so I want to learn plumbing.
All right.
Yeah.
Nice to meet you.
Thank you.
AE Draki.
Hi, my name is Aydin Draki. I'm with Avenue 5. I'm a regional maintenance manager, and I've been in the industry about 15 years. My strengths in maintenance, plumbing. So I've done plumbing for a lot of years. So.
Okay, what's your weak point? Something you want to get stronger at?
Everything.
Everything. I like it. All right. Be well-rounded.
Yeah.
Well, so nice to meet you. Mohsen?
Hey, good morning, guys. I've been in this industry for 5 years, and I'm with Blanton Turner right now as a maintenance manager. And yeah.
So your strong suit is what? What is the one thing you're strong at when it comes to maintenance?
Yeah, I'm good at plumbing, and besides that, I'm not good at HVAC, and yeah, something like that. And
Okay.
yeah, I'm going to improve in HVAC systems.
I definitely can help with that. Plumbing, though, plumbing's every maintenance guy's job security, right? That's what
Yeah.
we go to right there. Nice to meet you, Mohsen.
Good to see you.
Let's see, Rappel.
Hi, my name is Rafael. I've been in this industry for 15 years. I'm a maintenance supervisor with Epic Asset Management. And I'd probably say my strong suit would be appliance repair, and plumbing would be my worst.
Nice. Not very many guys. I could tell you. I teach cross appliance repair is their strong suits. That's awesome. Glad to be in your class. Nice to meet you.
Nice meeting you.
Ben.
Started from the bottom, now we're here.
Oh, that was weird. Good morning, Brian. Ben Watts. I've been in the industry about 5 years. Strong point, I think general problem solving, pretty good with all that, but definitely a weak point for mine is electrical work. So I'm looking forward to today's course and try to shore that up a little bit.
Awesome. Nice to meet you. Jeremy.
Welcome to Verizon Wireless. Your feature update could not be
Jeremy Lynn. I think he's frozen. We'll move on. Eric.
Yes, Eric, I'm with area maintenance manager with Avenue 5. I'd say my strong suit is probably just overall operations, how a building's supposed to be ran, staffing, et cetera. And then my weak point would probably be more of the electrical and, large mechanical stuff.
Awesome. Nice to meet you. Lexrel.
Hi, I'm Lex. I'm a senior service tech. I've been here in this industry 2 years. I'm training to become a maintenance supervisor, and what I want to get better at is learning HVAC and then appliance repair. Those are things I need to work on. I'm pretty good with plumbing and electrical.
Well, hopefully Rappel can help us with the appliance repair. Sounds like that's his strong suit. Well, it's nice to meet you, Lex. Let's stay here. Yemi.
Joining me?
Yep, morning.
Good morning.
Well, my name is Jimmy, and I working for Epic Asset Management for 2 years. I work for maintenance for around like 9 years already, and well, I don't know if I have prepared a stronger skills, but I like to deal a lot with electric and plumbing. I mean, I like to do a lot of troubleshooting with the electric when something doesn't work the way we want it.
Okay. Nice to meet you, sir.
Nice to meet you, man.
Roy. I think Roy's screen's blank. He went back to sleep. How about Carlos?
Can you hear me now?
Yeah, go ahead.
Hello?
Carlos, hold on. Let's go back to Roy for a second. He popped through there.
Can you hear me now?
Yes, sir.
There we go. Sorry about that. I was just explaining that I'm having some system problems. Webcam not working. Don't know why it worked yesterday, but
all right. We'll get through it.
Yeah, I'll marshal through. Been in the business for 26 years. Last 9 have been in maintenance. Service manager, 916 units, 2 properties. Operations, managing humans, what I excel at, or I need help in is probably managing humans.
We can all use some help in managing humans. I'd much rather manage a bunch of kids than a bunch of human grown adults. They're tougher to manage for sure.
Yes, they are.
All right. Well, it's nice to meet you, Roy.
Thank you.
All right, Carlos, you're up, buddy. Carlos, you have to unmute your stay, buddy.
Oh, there we go. Can you hear me?
Yes, sir.
All right. Hey guys, nice to meet you. My name is Carlos. I've been in maintenance here now for about 4 years. I started with Essex. When I first joined with Essex, I felt I had the skill sets to be a maintenance supervisor. So when I told them I'm looking to be a supervisor, jokingly, they kept on running me around in circles, telling me I'd become a supervisor when my supervisor dies or retires. So when I found Thrive, they immediately trained me. Within 7 months, I became a maintenance supervisor. I've now done 2 lease ups. I'm over here at Waterfront Place Apartments. My strong suits, I would say, are with painting, drywall repair, appliance repair, and maybe even electrical. Just that I never really dove too deep into electrical to understand in full depth and detail. Like, for example, like with these courses that I'm taking with the CAMT, I'm really enjoying it a lot because I'm actually learning like the proper verbiage and the components of an electrical system. I also think I'm pretty strong with implementing like administrative systems, right? Like preventive maintenance systems, routines, and also managing and leading. So yeah, I'm really enjoying what I do. I really like this industry. Nice to meet y'all.
Nice to meet you too. All right, let's see here. Micah, you're up.
Hi, my name is Micah. I work for Lincoln Property Company here in Redmond, and been in the industry for 11 years. I would say my strongest suit is HVAC work, and then I would say I would like to brush up on the appliance repair, get better at that and sharpen that skill. So that's what I'm hoping to take away the most from this course.
Awesome. Nice to meet you. Candace, you're just our IT girl, right? Our IT lady?
I think that was Lex. That wasn't me.
Oh, that was you. Okay.
No, that is
You're
not my strong suit. So yeah, my name is Candy. I've been in business about 7 years with FPI as the maintenance supervisor. I think I'm strongest at, and I love doing new builds and doing the punch list and working with construction to get the building set up and underway. But I'm not very good at reading schematics.
Okay.
So I'd like to learn that a lot more.
We can definitely touch on that and help with that a little bit. It's not too often that maintenance professionals, get the ability or have the opportunity to help with startups or new.
Mm-hmm. Yeah, I've done several properties this past year, so I find that part really exciting.
Yeah, that's pretty cool. Well, it's nice to meet you. All right, let's see here. Epic. Epic, is that right? EPIC? Yeah, that's you.
Yeah, hello, my name's Nathan Knopp. I'm the maintenance supervisor at West Mall Apartments in Everett. I've been doing maintenance for 6 years. Started out as tech, now I'm the supervisor after my maintenance supervisor retired. And this is my second career. I'm a retired Navy Chief Petty Officer and Air Launch Weapons Technician. And I'd say my strong suit is probably managing the chaos around here. And my weak suit would probably be troubleshooting these modern appliances that have circuit boards and, things that are less analog. The circuit board stuff can be difficult.
Absolutely. And I called you Epic because it says Epic at the bottom of your.
Yeah, I'm not very tech savvy about computers. Sorry about that.
All right, so Nathan, nice to meet you.
Yeah, thank you.
Let's see here. Farshad?
Good morning, everyone. My name is Farshad. I'm working for Pillar Properties as a maintenance supervisor. I've been in this industry for 5 years, and I'm taking care of the Corridon apartments at Seattle and also the corporate office. I used to work in heavy duty truck manufacturing company for 10 years as a mechanical engineer, but out of United States. And my strong strong point is leadership and drywalls. And my weaknesses are plumbing and HVAC.
All right. Well, it's nice to meet you.
Nice to meet you too.
Let's see here. How about John?
Hi, I'm John Palomares. I'm with Avenue 5 Residential. I'm an area maintenance manager. And I'd say probably my strongest category is plumbing. Want to know more about electrical and HVAC.
Nice to meet you, John. Who have I missed here? How about Paul?
Hi, I'm Paul Smith. I've been in the business about 18 years. I work for Epic Asset Management. I'm pretty sure I'm well-rounded in most areas for HVAC. HVAC's my weakness.
Okay. We'll definitely get some practice in that while we're here. How about Josh? Josh Feston, are you there, bud? I have to unmute it.
This is Roy. I'm reading the chat line. Josh Feston reports that his microphone isn't working.
Okay. We'll talk to Josh next time then. Bryce.
Hello, my name is Bryce Smith. I'm over here at Bell Jackson Street in Seattle, maintenance manager. Been doing it for about 5 years. Strong suit would just be hard manual labor, and my weak point would be the finer things of just about anything.
Nice to meet you. Victor.
Good morning, everyone. Like I said, my name is Victor, and I work for Epic Asset Management. And I've been with Epic for 3 years, where I have a role of a maintenance system manager here for supervisor. Pretty good on drywall, some way, I think. But my weaknesses is definitely HVAC and plumbing. I know a little bit of electrical, but pretty much open for new stuff.
Awesome.
I really appreciated all you guys for being here and all the sharing that you guys are going to be sharing. Thank you. I really appreciate it.
Awesome. Nice to meet you.
Nice to meet you.
All right. Well, I think I got everybody. Did I miss anybody? Awesome. All right. We are going to go. I've learned teaching across the United States that us as maintenance supervisors, maintenance technicians have a attention span of about 45 minutes. So we'll go 45, 50 minutes and take a few minute break, get coffee, use the restroom, do those kind of things. And then we'll get back into it. Does everybody has their books, correct? Does anybody not have their book? Awesome. All right. We're going to talk about electrical repair and maintenance today. And then we're going to talk about plumbing tomorrow. And when we talk about electrical, there's some course topics that we're going to go through. And it's going to talk about our roles and responsibilities as maintenance professionals, our basics and terms. We're going to talk electrical safety, tools and equipment, panels and wires, switches, receptacles, light fixtures, smoke alarms. We'll do some skill checks. So when we're talking about working with electricity, what is the key responsibility that we should pay attention to when taking or talking about electrical repairs? Anybody?
Safety.
Safety. Yeah, we want to go home with all 10 fingers, all 10 toes, standing upright, not blinded by the light. So safety is always our first priority. And when we talk safety, we have to talk about a few things. What does our surroundings look like when we're working with the electricity? What things do we have on us that could hold us to that electricity? So if we got a belt or a necklace or earrings or a wedding ring that could get involved in the situation? Are we wearing rubber-soled shoes? Are we in a place to work safely? And those things all have to come into play. And then knowing our limits. When should an electrician be called? When do we call a specialist? Anybody?
If you're not sure you can do the job safely.
Yeah, if you can't do the job safely, what else? I know it's early there, so we got to get our thinking caps on here.
Time constraints.
Time
Is the
constraints.
job too big for you?
Is the job too big for you?
That's when it requires a certification to get the job done.
Yeah, when you got to have a certification. Not as us maintenance guys are good at a lot of things, but masters usually have none. And there's got to be times where we know our limits. Some of the things I've experienced as a maintenance professional, as in managing humans, is I find that there's some maintenance guys that think they can do everything, and by doing that, they actually make the scenario worse. And so we as maintenance professionals, we as human beings need to know, man, I don't know enough about this to address it safely. I don't know enough about this to do the job properly. And I know that, especially in maintenance, in our industry, budgets are, our first thing. It's not in the budget. We can't afford to call an electrician. Well, they may not be able to afford to call the electrician, but I can guarantee you they can't afford to pay all your medical bills and do all the things they need to do after the fact when you get hurt. And so I'd much rather pay the extra and ruin the budget a little bit to call the guy that can do it right than to have to take care of you and your medical bills because something went terribly wrong. So when we have to call electrician, when code requires it. Now, code is different across the United States, depending on what city you're in. So wherever you guys are, whatever your code requires, it's beyond your skill set. The size of the job is too big, or you're trying to manage time. You've got too much on your plate. There's no possible way you can add this to the 9 million things we're expected to do as maintenance professionals on a daily basis. What is electricity? Anybody have any ideas or know the right answer? I can tell you that before I took this class, I didn't know the right answer.
Electrons moving across a conductor.
Yeah, electrons moving across a conductor. Let's see if I can move mine. If you look at this, we've got our protons, our neutrons, our electrons, and our nucleus. Now, do we need to know all of that? No, not really. This is the basic definition of what electricity is. Now, what can we do here? So this is talking about Ohm's law. How many of you guys have heard of Ohm's law before? Okay, a few of you. How many actually use it? Not very many. So Ohm's law is a very cool way to know the right answer to an electrical question. And as a heating and air professional myself now, I use this more often than I ever thought I would. When I took this class and got certified in it, and I was just a maintenance guy at the time. So, I really didn't think, I pay much attention. I don't know this. I probably don't need to know it, but it actually helps. And I'll show you how it helps when we get into heating and air conditioning and, hot water and that kind of thing. But in this scenario, it's a pie chart. And we've got watts up top, volts at the bottom left, and amps in the bottom right. And the question is, how many amps does a 60-watt incandescent bulb use? And by using this pie chart, we can figure it out. If we pop in 60 up top, our volts are 120, because we all know 120 volts controls our light fixtures. And we divide that 60 by 120, we get 0.5. And that 0.5 tells us how many amps a 60-watt incandescent bulb is using. Now, why is this important to us? Why do we need to know that?
So you don't overload the circuit.
Okay. First and foremost, so we don't overload a circuit. Yeah. Our circuit breakers say 15 or 20 or whatever it may be. And if we're We have that person that says, every time I turn my curling iron on, or every time I turn the switch on in my bathroom with my iron plugged in, my breaker pops. Well, we take into consideration, well, we've got, 5 or 6 Hollywood bulbs at 0.5 a piece. Your curling iron's another 3 amps, your iron's another 6 amps, whatever it may be, to come up why we're overloading that circuit. What else is another reason you need to know that? Kind of thinking outside the box. Us as maintenance professionals kind of get in this path of where we're wearing blinders. It's always been done this way, so we're going to continue to do it this way. We're always going to need, if it's a light bulb's out, we're going to change the light bulb. We don't really think past what we've already got in front of us. And things are changing. We're becoming more energy efficient as a society, and things are becoming more green. And 0.5 amps on an incandescent bulb, where our new LEDs are 0.01 or 0.2 come into play. Well, I can change these incandescent bulbs and save myself some amp draw. I can save myself some kilowatts used. I can help the company by saving them on the cost of electricity. Those things come into play more often now because we're becoming more green and wanting to save money. Now, can we use this in other scenarios? Well, yeah. If we look at this Ohm's law pie chart, on the last one up top, we had watts. In this case, we have volts, amps, and ohms. And it's asking us how much resistance. What is resistance? Do they know? Resistance is also known as ohms, and it's how easily electrical current can flow through something. We're going to talk more about ohms, especially when we get into heating and cooling and into working with our water heaters. But in this case, we need to know how much resistance is in a 60-watt incandescent bulb. Now, do we know our volts? Feel free to unmute and answer. Do we know what
120?
Say that again?
120?
Yeah. So we have 120 volts. What was our amps on that incandescent bulb from the previous slide?
0.5.
0.5. So if we take that 120, divide it by that 0.5, it tells us that we have 240 ohms of resistance. That's how easily that electricity will flow through that light bulb. Now this is going to come a little, I'm going to just touch on it for heating and cooling wise. How many of you guys have electric heating on your property? A few of you. How many of you have electric water heaters on your property? Yeah, a few of you. Can you tell me, without doing anything right now, how many ohms of resistance your electrical water heater element should have? Anybody?
13.
Say again?
Is it 13?
Depends. Depends on how many volts you have. Depends on what the draw of that element is. On average, if it's a 220 volt electric water heater, and our amp draw is 19 and a half usually, then our ohm readings around 11.3, but they're all a little different. No two are the same. I'm just touching on this for a second. We'll go back to it tomorrow on plumbing, but when we're dealing with our electrical elements in our water heater, how do we test them? How do we know if they're bad or good without opening it up?
Resistance.
Continuity.
Testing for continuity.
So that's the mistake that's often made, Bryce, is that we could use continuity. So with those elements, if everybody knows what an electrical element in a water heater looks like, it's almost like a small version of a copper pipe. And if you've ever seen a copper pipe freeze with water in it, they split. They don't break all the way through, they split. Now, sometimes our elements inside our water heater break all the way through, but sometimes they split like that copper water pipe that's been frozen. And if they split like that copper water pipe that is frozen, could we still get continuity, Bryce?
100%.
Nick, would that element be good though? No. So in this case, when we're testing water heaters, we have to know and we have to test with resistance and have to know what that resistance level is. And by using our Ohm's law, 20 volts, 19 amps should give us around 11 ohms of resistance. So I know when I test that element in that water heater, if I don't get 11 ohms, if I get something crazy, I know that element is bad. That's how to apply this to our current day of work, and it should make our job easier. You know, and the other part of this is that I work with maintenance guys, and I've worked with hundreds of maintenance guys. In fact, I oversaw, I had 274 maintenance guys on my staff when I oversaw Selden. And the mistake that is often made as a maintenance professional is that it's so easy for us to become parts changers rather than proving, troubleshooting, and knowing what the problem is. Oh, the water heater's not working. Well, I'm going to change the elements. I'm going to change the thermostats. And you're going to solve the problem probably because you changed all four of those things. But do you really know what the problem was? And us as maintenance professionals, that's what we should be, is to be able to troubleshoot and say, I know exactly what the problem is because now I used Ohm's law. I know that bottom element didn't have the right amount of resistance. The rest of it did. And I replaced the bottom element. We'll talk more about parts changing and doing it the right way as we move on. So a 60-watt bulb has 240 ohms when operating. Any questions on Ohm's law? If you look up Ohm's law, you know, we've all got these fancy smartphones now. It's our little mini computer we carry in our back pocket. And you guys, some of people I don't like drive and text at the same time, learn all kinds of stuff. But if you look on there, there's many different pie charts for Ohm's law and many different things you can pump in these pie charts to figure out. So take some time, learn it a little bit, practice it. You know, the more you practice it, the easier it becomes. Use it in your day to day. We're going to need it when we get into, you know, troubleshooting appliances. We're going to need it when we're troubleshooting heating and air conditioning equipment and water heaters. So it's a good thing to know. All right, we talk about electricity and its relationship with plumbing. And if we kind of think about this, it's kind of the same way. You know, if we look at our sink here up top, as our water flows out of the faucet, it's the same way our electricity flows through our black or hot line coming in. So we've got power under pressure, a volts under pressure, and we got water coming out under pressure, same kind of principle. As it goes to our light, it leaves the neutral with no pressure. There's no pressure on that white or neutral line, just as the water leaves our plumbing under no pressure through our plumbing. And so it's kind of a far-fetched, not far-fetched, but a relationship that it's easy to visualize and to understand. So comparing it, like I just said, this is what I just touched on. We talk about a couple different things. The comparison, voltage is the same as, excuse me, that back. Our voltage we measure in volts. Our water pressure we measure in pounds per square inch. And so that's the relationship between them two. Water coming out of the faucet is under pressure. Our voltage coming in is under pressure. And that's the comparison there. And as they're leaving, we've got gallons per minute that we use, and the amps that we use is what we measure our voltage in. Some key terms we're going to talk about as we go through this course. We're going to talk about amps and circuits, conductors, continuity, current, hot wire, line, load, neutral wire, ohms, overload, power, volts, and watts. Now, when we talk about electricity, we have some key things that we need to pay attention to for our own safety. One is arc flashes. 2, electrical fires, and 3, electrical shock. What are some things we can do to minimize the possibility of these 3 things?
Wear rubber.
Lodo procedures.
Yeah.
Go.
Outside go.
Go ahead. Say again.
Oh, just saying for electrical shock, lockout, tag out.
Yeah. So he said Lodo. So lockout, tag out. I heard PPEs. I heard they had rubber sole shoes. Anything else?
One of those little testers before you touch anything.
Okay.
Multimeters, insulated equipment.
Yes. Good. So if we're looking at these things, it's important to know the reaction to current. So 0.5 to 1.5 milliamps, a tingling sensation at the point of contact. 1 to 5 milliamps, muscle contractions. And if you look all the way down here at the bottom, I don't even like the way it sounds. 5,000 to 6,000 milliamps, your organs burn. I don't ever want to experience that, and I don't want to know anybody that experiences that. There's a few things we need to pay attention to. One, when we're working with electricity, we always need to wear our PPEs. We always need to turn the power off as close to the source as possible. We need to use our lockout, tag out procedures, which we'll talk about here in a minute. And there's a word that we're going to talk, and I'm going to beat it in our heads over and over again that starts with a V. Does anybody know what that word is?
Verify.
Verify. Yeah, we want to verify every time that the power is off. Now, there are some power sticks that you can use. You know, push the button, put it next to the wire, it beeps, it tells you, hey, there's power, there's no power. I've never been a fan of those. Again, there's more than one way to get to the grocery store. Some of them may take a little longer than others, but still gets the job done. I'm a guy that believes in using his multimeter to verify the amount of power that I have at my source. I had a maintenance professional, his name was Charles. When I first started in maintenance, was trying to teach me maintenance, and we were working on an electrical water heater. He asked me to go turn the breaker off to the water heater. And so I went to the panel in this apartment. It said water heater, had a double pull breaker, shut it off. Charles went in there to work, zap, gets shocked, tossed back out of the closet. He goes, go back and shut off all the breakers. So I went back, I shut off every breaker in the apartment. He went back, got shocked again. Finally said, go to the the laundry room and kill the main. So finally went to the laundry room, killed the main, and shut the power off. Now, could he avoided all of that? He was teaching me wrong. I was 19 years old. I didn't know any better, but could he avoided all that? Absolutely. If he would have had a multimeter and tested power coming in, he would have known right away that, hey, there's power. So we want to verify every time, no matter what, that the power is off. Using our personal protective equipment. Now, is the personal protective equipment the same thing every time? It's not. Every job can call for more or less depending on. Now, in this case, we see this gentleman, he's wearing gloves. He's got eye protection on. He's got a voltmeter that he is verified. How many of you guys have gloves that you wear on a daily basis? When working with electricity, there's something we need to take into account. What is that when it comes to our gloves?
What they're rated for?
One, what they're rated for. Secondly,
that the gloves have rubber around the fingers and wherever you grab. Yeah.
There's one really important thing that I take into account is dexterity. Can I still use my fingers and hands in these gloves safely. A lot of times we get these gloves and they're big and they're bulky and you can barely move your fingers. Well, that's not really the best or most ideal set of gloves for working with electricity. We need to be precise. We need to be able to move and test things properly. And if I have lost the dexterity in my hands, then I feel like I have lost the ability to work safely. And so we need to find gloves that work for us safely, that are rated for the electricity that we're dealing with, but that don't take away from the dexterity so that we are able to test and do the things that we need to do. A lot of times, I say this jokingly, they always put the furnace, the breaker box, the water heater in the biggest possible closet in the apartment. So we always have the most amount of room to work. Isn't that right? No, they're always in the smallest closet. You got to bend sideways and be a contortionist to get into them. You got to take your belt off and half your a tire off just to fit in the closet door that's, so wide. All those things are taking away from us working safely. And so if I've already got to be in a tight and confined space, I need to be able to move in a safe manner. And so I have to take these things into account. What am I putting on myself? What am I putting in my way to protect me? And so you got to take those things into consideration. I make sure that I always take my belt off. I don't wear jewelry anymore because I don't want to. I've been electrocuted. I say electrocuted. I've been zapped, and I don't like that feeling. I don't want to experience that. So if you're in a position where you have a set of gloves that have kind of taken away from your dexterity, look into getting some other ones. And there's a lot of places that sell those and give you the ability to try out different ones. Multimeter. How many of you guys have? Well, we'll talk about meters in a minute. Let's just move on. Tools, insulated tools. If you take care of your tools, they will take care of you. There is something that we need to do with our tools. We need to make sure that they are cleaned. We need to make sure that they're lubricated well, and we need to make sure that the insulated handles on them are not damaged, nicked, cut, peeling from the ends, missing. True story, I started in maintenance back in 1997 in Oklahoma City. To be honest with you, my salary was $825 a month as a contractor. I didn't make hardly any money, and I had to go buy my own tools. And when you're short on cash and you're fresh out of high school and just had a kid, where do you get your tools? You get it at the Dollar General store. So I went to the Dollar General store, bought all the tools I could buy, and I had that really nice metal pliers, not really nice, but the one metal pliers that they always carry at every Dollar General store for $1. Couldn't figure out why this air conditioner wasn't working, was on the roof. It's kind of lightly drizzling that day, called the owner, said, hey, I'm not sure why this air conditioner is not starting. And he says, I want you to check the wires in the disconnect and make sure they're tight. So I took my metal pair of pliers that I just got from the Dollar General store that had a little bit of drizzle on them, stuck them in there to see if the wire was tight, and boom, got blown back across the roof. I said that to say this: get the proper tools for the proper job. If you're working with electricity, they need to be well insulated. If you're a pair of channel locks is not a hammer. A hammer is not a pair of pliers. Use the proper tool for the proper job. And always be aware of your surroundings. In that case, I was a 19-year-old kid. I didn't know any better and almost got thrown off the edge of the roof because I wasn't aware of what my surroundings were as well at the time. So I've seen maintenance guys, again, when I became the head of Selden company for all their safety, I told them when they picked me that they hired the wrong guy, that I've almost been electrocuted on a roof, that I've fallen through a scuttle hole, that I've trimmed my whole wrist with a box knife trying to trim out a door hinge. I really wasn't the right guy to take care of safety. And they told me that because of all those things, I was the perfect guy for safety. And so I would go look at guys' tools and look at guys' ladders and what they had in their shop. And, our needle-nose pliers, the handles are peeling off the bottom of them. Our insulated screwdrivers, the insulation's going away. And we really need to make sure that if those are the case, that we replace those. When working with electricity, we also need to be aware of what ladder we're standing on. If If you've got aluminum ladders, they're the thing of the past. Fiberglass is the way to go. If you're working on electricity and you're standing on an aluminum ladder and I see you, we're going to probably fight because it's going to be saving your life more than likely. All right. How does it work? Well, the electricity starts the power plant, goes to the substation, from the substation to the transformer, from the transformer to the service head of your home or apartment complex or wherever we may be, into our electrical meter, and from our electrical meter into our service panel, into our junction boxes, switches, and outlets. Have you guys deal or work on an affordable housing property? No. Yes. Yes. Okay, a few of us. So you have your REAC inspections. Is that going to pass our inspection?
No.
No, definitely not. If you are on a property or just come onto a property and you're new at this property, these are some things we should look for. This is a level 3 safety deficiency when it comes to REAC, but it's obvious to see that this junction box is way overloaded. How would we attack this problem? How do we solve this problem?
Add another junction box.
Could add another junction box. Do you know where all those wires go?
Oh, certified electrician.
Yeah, I absolutely would. In this case, this is more than I'm going to deal with. Now, could I absolutely do it? Yeah. Could I do it in a timely fashion? Not as timely as a certified electrician. And code's going to come into play here. And so I want somebody that is certified to do that. So if I see something like this on my property, I'm getting an electrician out to make it right. And that needs to be a lot less than that box. That box needs to have a cover on it. If you even look here on the right-hand side by the PVC pipe, this one is just electrical tape. There's not even a wire net on it, just tape hanging. So all those connections needed to be redone as well. So from our electrical breaker box into our electrical outlets, into our lighting fixtures. This has a grounding wire. What do we do with that? I've had guys just cut these off, and we don't need that wire. Is that the right thing to do?
No, I guess that's something that we fix ourselves, and no, we wouldn't want to just cut that off. We want to replace it.
We want this appliance to be grounded. So we need to ground. That's why that wire is there, to ground that to the box or ground that back to the circuit panel, so that if this fails, it trips the breaker rather than starting on fire. And so this grounding wire is very important. I've had some service technicians that cut that grounding wire off that condenser fan motor out at the air conditioner or the fan motor in the furnace, and we have to go get another one because that's the new one on, because that's not how we do things. All these things need to be grounded. If there's a grounding wire there, it needs to be used. Our electrical switches. Now, if we're looking at our components here coming out of our electrical panel through our electrical outlet, from our electrical outlet to our light, to our switch, and then back to our panel. I was going to test this with my electrical voltmeter, and I tested it at the 2 wire nuts just to the right of my electrical outlet. How many volts would I get?
120.
I don't think you'd get anything, would you?
You wouldn't. No, because that's a 120 volt line, and our voltmeter reads the difference. And this is the same 120 volt line. So right now at these 2 wire nuts, I would get 0. If I went from the top right wire nut to the top left wire nut, what would I get?
That's the 120.
There's 120, because I've got a difference. I got 120 volts in my hotline. I have 0 volts in my neutral line at the moment. And so the difference between those two are 120 volts. All right, so we talked about our tools we need: insulated screwdriver, insulated needle nose pliers, wire strippers, cable ripper if you're dealing with Romex, that rips that exterior coating on the Romex off. Non-conductive fiberglass ladders. They are more stable than wood, obviously, and they don't conduct electricity. So it's easier to work on electricity with them. If you're going to replace aluminum, if you're going to replace wood, fiberglass is the way to go. Now, however, if you've got a 40-foot ladder that you need to get onto the roof, fiberglass is great, but they're very heavy. We had fiberglass ladders on our service trucks, and a 40-footer is tough to deal with. You're going to have your muscles working in order to get that up and down. So sometimes if it's easier for you to get aluminum ladder to get up on the side of the building, they're a little more lighter weight and easy to move around. Lockout, tag out are important for a few different reasons. One, in property management, there are so many variables that are around us when we're working with electricity. Yeah, we may be in this apartment, we can shut the breaker off, but who else is in that apartment with you? And what are the chances that that power can be turned back on and discharge electricity by accident? So this absolutely prevents that from happening and protects you from getting electrical shock. So you have one of these. It's not just something you need to have on your safety shelf to make OSHA happy if they happen to show up, but you actually need to use it. I had a maintenance guy, again, safety, send me a picture of his safety wall, and he had a lockout tagout box, and the rags were stacked on top of it, and his safety glasses were still in their Raptor, but the Raptor was covered in dust and was hanging on the shelf. And I told him that his lockout tagout box needed to be ready to be used and not holding up the rags. And he actually had to take the safety glasses out of the package for them to absolutely work. And then he erased me off of Facebook and told me I couldn't see his safety wall anymore. But anyway, you got to have them, you got to use them. If you are the one that is locking it out and tagging out, you're the only one that should have a key to that lock. And so nobody else has the opportunity to do that. Now, lockout tagout we use here in electricity, but we can use it for any kind of power source. And when we get into plumbing and we get into the other things, lockout tagout could be a water shut off, a spring, thermal, whatever, pressure, electrical. We can lock out all those things. And so don't be fooled that it's just an electrical thing. It's an every power source kind of thing that can cause us harm to our bodies or to our property. How many of you guys have a voltage pen or voltage detector? Quite a few of you. Awesome. You guys like it? Use it a lot?
Seems handy. I don't trust it a ton though.
Yeah, I mean, I have one. I've used it probably a handful of times. I'm the same boat. I just don't trust it. You get that, faint beep every once in a while, and you're like, shit, is there power there or not power there? When it comes to a voltmeter, I'm not second guessing it. I put my 2 lines on there. It's a number that I can process in my little pea brain. Oh yeah, I've got 115 volts, or I've got 30 volts. So if you have one of these, great. You should also have a voltmeter though as well. How about a plug-in testing tool? These are great to have. Big fan of these. Tells you if you have it grounded or hooked up wrong or polarity reversed. Easy way to test your electrical outlet or your GFI. If you don't have one of these, this is a pretty handy tool for a maintenance professional. Multimeter. Go ahead. Somebody's unmuted. How many of you have a digital multimeter? How many of you guys still have a analog meter? You have an analog meter? You probably keep it right next to your autographed Bible at home. Analog meters are the thing of the past. There's too many things that are involved in order to get sometimes an accurate reading. Josh says I have both. I had both for a while. I threw the analog meter away. The new ones are auto ranging. They're more accurate. When it comes to like microramps and things of that nature, you'd have to wrap a wire 10 times, put it around a wire, and then put the analog meter on it to get an accurate reading. You don't have to do any of that stuff with your digital multimeters. I'm not a salesperson for any brand. I've had Fluke, I've had UEI. I currently have the Field Piece HS33. When people ask me, hey, which one do you prefer? I prefer that, and this is the reason why. Back in the early 90s, when I went to college for heating and air conditioning, I had a scholarship from the school I went to, so budget wasn't a big deal. I was a cocky, arrogant butthead and decided when we did a voltmeter for my electrical refrigeration theory class, that I was going to get the biggest badass meter I could find. And so I went to Johnstone's heating and cooling place here in town, asked for the biggest badass meter they had, and I bought this $680 Fluke meter that did everything from hertz to temps to volts to you name it. It had a dial for it. I took this class, was ready to be the hero, and my professor Jim said, "That's a pretty badass meter." I'm like, "Yeah, it is. I'm pretty happy with it." And he said, "Show me how it works." I had no freaking idea how to use that meter, and it did things that I would never use in a million years. And so I took that meter back, and I really focused on. I'm more focused on it now that I'm teaching and I have a business of what things I need a meter to do. And that Field Piece HS33 does volts, it does amps, volts AC and DC, amps, resistance, continuity, capacitance, temperature, and microamps. And when it comes to my business, those are all the things we use. And we use those same exact things as a maintenance professional. AC volts is when I'm testing my lights and my outlets. DC volts when I'm testing my golf cart battery or my emergency light battery. Resistance, we just learned we're going to use to test our water heaters. Capacitance, I can test my switches with. My capacitors with in my air conditioners. Continuity, I could test my switches with. Temperatures, giving my temperature drop, and my temperatures for superheat when I'm dealing with my superheat and subcooling for charging HVAC systems. And it has an amp clamp. On these two meters, this top left one, the orange one, it has an amp setting, but in order for me to get the proper amps on that, I have to take those pins and puncture the insulation on that wire to get an amp reading, where on the one on the bottom has an amp clamp. I take that clamp, I clamp it around one wire, and it gives me an amp reading. And so for me, my amp clamped Field Piece has everything I need. Now, it also has a detachable clamp. And so there's some other things I can buy to add to that meter. I never bought them because I don't really need them, but it's affordable as well. I think it's about $150. It does everything that I needed to do. So if you have a voltmeter, if you don't have a voltmeter, find one that you know how to use and that you're comfortable with. It doesn't have to be the biggest, baddest meter. And if you have one now and you don't know how to use it, it's time to pull the manual out and learn how to use it so you can use it safely. Any questions so far? Yes, sir.
Hey, quick question. So pretty much in this class, we're just going to be going over pretty much like the previous hard skills course that we took online. because as we're going through the class, it feels like it's just a review of what we learned in the.
Yeah, so it's going to be very similar all the way through it today. There'll be some things that we do differently that aren't on there. We'll do some skill checks in a little bit as well.
Nice.
That's just the way they set it up.
So I have my own multimeter, right? And are we going to be doing any an engagement class where we're like, I don't know, we try to test a component live?
Yeah. So I'll be there to see you guys first week in December. And we'll do 2 days of some hands-on stuff.
Oh, cool. Nice. Yeah, because a lot of times that helps too. Because you're right. Like when you were telling your story about the multimeter, how it's like, I don't even know how to use it, but I've always carried one. I was like, yep, I can relate because usually it's just to test if an outlet has power to it, and that's about it, right? I've never used it for ohms or anything else. And,
Absolutely.
Yeah.
Yeah. So I'll be there. I think it's like 6th and 7th or 7th and 8th, something like that, December. So once we get through all of our online stuff, and then I'll be there for 2 days. We'll do some hands-on stuff.
Cool. Also, since this is this isn't going to go through detail of how to use a multimeter, do you recommend any classes or courses, the online courses that do go into detail?
Let me look on that because there's different everywhere else, and I don't know one off the top of my head. But let me do some research on that one.
All right, no worries. Thank you.
You're welcome. All right, everybody's back. Let's get moving here. All right, so we talked about our multimeter. Some questions. I had a question while you guys were on break about doing some hands-on stuff, and I'll actually be there at your place first week of December. We'll do some hands-on. So I'll have you bring your meters for that. We can do some testing and looking at meters. And if you have questions, and if I can help go through them. How to use an multimeter. We're going to watch a couple of videos here.
Today, we're going to show you how to use the multimeter.
Are you guys able to see this screen?
Yep.
Yes.
Yes.
How to check amperage, volt, continuity, and resistance.
Our technician is now going to show us how to check for voltage. He's going to set the meter to the voltage reading and to a high setting to protect the meter, and he's checking the outlet to see how many volts you have. You have 120 volts coming in from the outlet. So that means the outlet is hot. He's checking the ground terminal from ground to hot. He's getting 119, 120 volts. So the ground is good. So we have voltage to the outlet.
Now that we have shown you how to use the multimeter, we're going to show you the difference between continuity and resistance. Continuity is a continuous path between point A and point B. Resistance is going to be in opposition to the flow of electricity, and it is measured in ohms between point A and point B.
Our technician is now going to show us how to check for resistance. He's going to use his meter and set it on resistance. And he's going to check the resistance and the heating element. He's placing one side of the meter on the one side of the element and the other on the other side. And he's getting a reading of 11 ohms. So this means that that element has 11 ohms of resistance and is good. Our technician is now going to show us how to check for continuity. He's going to use his meter, put it on the continuity setting. He's going to be checking a switch, a fuse, and a breaker for continuity. Our technician is going to show us how to check the switch for continuity. He's got the meter on continuity, turn the switch on. It's working, so the switch is good. I'm going to check the fuse for continuity. Check between the two terminals, and the fuse is good. Now he's going to check the breaker. He's going to put one side of the meter on the power coming into the breaker and the other side to the power going out of the breaker to check the breaker for continuity. And the breaker is good.
So they had 11 ohms of resistance, 11 ohms of resistance on that electrical element. If we had 220 volts system, how many ohms would we have? So 220 volts, and that was 11 ohms of resistance. How many amps should it have? Back to that Ohm's law.
220 over 11.
So 220 over 11. Yeah, 220 divided by 11, and that gives us what? 20. So then we know that when we amp check that element with power turned off or power turned on, we should have 20 amps. Back to knowing our how to use Ohm's law. All right, use a multimeter. You need to know, one, how your meter works. Is it auto ranging? The difference between infinity and zero, and the difference between continuity and resistance. It also talks about listening to the resident describe the problem. What do you think that means? How can that help us?
We can better diagnose the issue.
Yeah, we can better diagnose the issue. Now, a lot of times, is it us listening to the resident describe the problem? No. Usually somebody in the office is answering the call to write the work order, correct? And I can't tell you how many times I've had a work order that says bathroom sink broke, or faucet broke, or electrical outlet broke, where we as maintenance professionals can help our office staff become better at what they do by having them ask some more questions. Which faucet? What is it doing? When did it start? What does the appliance sound like? Which outlet is it? Because if we just get faucet broken and there's two bathrooms and a kitchen, it takes us a few extra minutes to figure out which faucet it is, what the problem is. And we have so many things going on in our day. If anybody can help us save a few minutes here and there, we'll be able to get a few more things done and become more efficient. Two, asking it what it sounds like. We know as maintenance professionals how many, what our refrigerator is supposed to sound like, what our dishwasher is supposed to sound like, because we're in apartments all the time. And we know what, usually if you're on a property, they all have Hot Point fridges or GE refrigerators or GE dishwashers or whatever it may be. You know what that dishwasher is supposed to sound like. You know what that refrigerator is supposed to sound like when it's running right. I can tell you right now, I can walk through any of your properties with the air conditioning running and tell you, man, that air conditioner doesn't sound right. Or man, that one's running pretty good. Just by the way it sounds. Us as maintenance professionals can become have a superhuman power by just listening to what those appliances or equipment sound like and know right away if it's running properly or not. And then checking our surroundings. We're measuring volts. We're measuring the difference in electrical power. It's the difference between our hot lead and our, in this case, neutral lead. If we had 220, it's the two different 120 volt lines, our 200, our 110 volt lines. And so adding those together gives us the 220. In this case, if we go between our 2 points here, how many volts do we get?
That should be 120.
120. Which one of those two is our power side? Is it the larger side or the smaller side?
Small one.
Smaller side. And what's our bottom one?
Ground.
Ground. Yes, we're going to check our hot, we'll check our neutral, and the difference between those two gives us our voltage reading. Continuity. Continuity states that there's electricity that will flow between 2 points. So if I have a piece of copper wire from point A to point B with continuity right now, this would tell me, yeah, there is continuity. But if I cut this in half, electricity can't flow from point A to point B, so there would be no continuity. And that continuity usually is just a beep on your meter. You know, if you put your two leads together, it gives us that beep sound. For continuity and resistance, testing the power must be turned off. If you try to test continuity or resistance with the power on, you will fry the fuse or fry your meter. Trust me, I've learned from experience that that's never a good thing. It gets expensive. All right, measuring ohms, measuring the amount of resistance. Meter measures how difficult it is for electricity to travel between the leads. The higher number, the more difficult it is for electricity to flow. So we talked earlier with that incandescent bulb having 240 ohms of resistance. That one's better insulated. It's not as easily, that electricity doesn't flow through it as easily as that electric heater wire we just showed, where it only had 11 units or 11 ohms of resistance. Electricity is going to flow through that pretty freaking easily. So the higher the number, the more difficult it is for electricity to flow. The lower the number, more easily it flows. Better conductor. All right, in the back of your books, there is a skill check. And this is under skill check number 2, electrical maintenance and repair. Let's take 5 or 6 minutes here, maybe 10 minutes. I don't know however long it takes you. When you're done with what I give you, shoot me a chat that you're done. We'll wait till everybody gets done. Let's get skill check 1 through 14. 1 through 14, and I'm going to help you with 14. It says what, and my book's older, so mine might not say the same thing. Nick, can you read me what your number 14 question says?
Sorry, I'm still trying to find the electrical part.
It's in the very back center, skill checks, back of the book's tab, skill checks, and it should be skill check 2.
It's what types of voltage are found.
Okay, so let's talk about it real quick. What types of voltages are found in apartment homes? We talked about the 120 volts, and we talked about 220 or 240. Am I missing anything?
24 for the doorbell.
24. Yeah, our secondary power. All right, so that's the answer to 14. 240, 120, 24. So 1 through 14, when you're done with those, writing your answers in, this will help you with your studying for your test. Shoot me a chat that you're completed.
1 through 14, huh? My number 14 says, what is vacant lock? I don't know what.
That's part of skill check number 1. You'll want to flip a couple pages and then you'll go to the electrical.
Yeah, you're still in skill check. Interior maintenance. We need to get to.
Okay. Yep.
Got it?
Yes.
Perfect. Then we'll go through them together here once you're finished. Most said it's skill check 2. It's in the back of the book under skill checks. It says electrical maintenance and repair in that skill check section. It doesn't only have a page number on it. So it's the back tab says skill checks. Skill check 2, 1 through 14. Okay, it looks like everybody's just about getting done. Let's go through them together. If you're not, if you don't have them, fill them in as we go. Number 1, Micah. And when I call on you, you'll have to read the question and unmute your.
When is it acceptable to call an electrician? I put down when the job's too big, whenever code requires it, or whenever you're just too booked, you can't get to it in time and manner. So
Yeah, size of job, time management, beyond skill set, code requires it. Number 2, Candace.
What is the measurement for electrical pressure? And I have volts.
Volts, yeah, voltage. 3, Nathan.
Okay, so what is the purpose of having different size wires? I put to carry various amounts of currents.
Yeah, different amperages. Absolutely right. And we'll talk a little bit more about that as we progress down this learning. Number 4, Ben.
What is an amp? And I put that's electrical flow.
Yeah, or current. Yeah, current. 5, Josh Feston. Oh, you're the one whose microphone's not working. 5, Eric.
What is ohms, measurement of resistance?
Yeah, measurement of resistance. Yimmy, number 6. Yimmy, you there? Oh, apparently no. Farsad, you want to do number 6?
Sure. A measure of electrical power.
Yeah, amount of power used. What is wattage? Number 7, Lex.
What is the first thing you should do before working on an electrical device? I have verify for power and then shut off the power and verify again.
Yeah. So we should shut off as close to the device as possible, lock out, tag out, verify. 8, Nick.
Describe the lockout tagout procedure. I have this as the process of turning off power and eliminating the possibility of somebody turning it back on. So lock out the device. No one has access.
Okay. Number 9, Aiden.
What's some of the personal protective equipment that you use in electrical? Gloves, eye protection, and rubber shoes.
Okay. Is there anything else we can add to that list? I like insulated tools and multimeter as well. You know, multimeter is a tool, but it's also personal protective because I'm able to verify if there's power or not.
Okay.
Number 10, Sean.
Number 10. Oh, it's a receptacle that has a shut-off circuit or a shut-off gate inside of it if a short circuit occurs.
Yeah, it's a ground fault circuit interrupter. Ground fault circuit interrupter, and it's a safety. It's another safety, especially around wet areas or water areas. Number 11, Mohsin.
Yep. Where does the power come from? It's coming from breaker panel or electricity meter in the unit.
Okay, so let's go back a couple steps before that. Where does it initially come from?
Oh,
From the power plant? Power plant, right?
Yeah, power plant.
Number 12, Paul.
How does the power company measure the electricity we use? I put an electric meter.
It does, but what does it measure it in?
I think it's kilowatts, isn't it?
Kilowatts. Yeah, kilowatts.
Watts.
13, Bryce.
What protects circuits from shorts and overloads? I put ground, GFCI, AFCI.
Okay, anybody have anything different? Gary, you have something different there for 13?
For the breakers and GFCI.
Yeah, breakers and GFCI is the right answer. And then we all know 14. We talked about that before we started. 240 volts, 120 volts, and 24. All right, if we're looking at the screen here, what are some things we could take away? Well, some of the properties built pre-1972 had aluminum wiring. And if they are the same owners as they were in 1972, they're currently grandfathered in. However, if the property has changed hands, or having issues like the ones we see here, we need to bring it up to current standards. Now, what is the problem with our top left picture?
They got the ground wire capped off.
Say that again.
It looks like they have the ground wire capped off.
You got the ground wire capped off. What else?
Those things blew up.
Say that again.
There's an arc fault.
Yeah, so when we connect aluminum to copper, since that aluminum, as we run electricity through it, gets heated and it becomes soft, and the connections become loosened and they start to arc. And that's what's happened here. There's not a tight connection, so between the two of them, it starts to arc. It gets hot, melts the wire nut, which was not the proper wire nut for a aluminum to copper connection. They make specific lugged connections for these because you really need to make them better, and definitely need to hook up the ground. So both of those are improperly repaired. We look at Romex. This is solid core wire, but they come solid core or stranded. We have PVC insulation or wire insulation on them. Treated paper is our separator and our sheath. And I remember our tools, we had that cable gripper. That's what that does, is it rips the sheathing off these and allows the copper wire to be shown. Our wires to be shown so we can hook them up. Color coding. Now, I can tell you this is a rule to go by, but in property maintenance, it could be whatever wire the maintenance professional had that day. So you can't trust what you see. I've gone to furnaces where they've backdrafted on a property and the maintenance guy only had black wire. So all the wire in the furnace was black, and so nothing was coded, and you didn't know what, and so we had to start over. But normally, hot wires are represented with black wire. Red is usually a switch leg. You don't see much of a black with a white stripe or red with a white stripe much anymore. Neutrals are white, gray in older buildings, and then ground, bare, or green. Note that these color codes are only for primary electricity. Primary electricity being 120 volts or 220 volts. When we get into our 24 volt, our secondary voltages, these rules don't apply. And so you can't, when we look at our thermostat, for example, it has a green wire in there, and that green does not mean ground. So this only applies in our primary forms of electricity. However, we cannot trust. Again, we have to verify using our multimeter. Now, wire size. We talked about wire size in our skill check, and that comes into play based upon the amount of current or the amount of amps something needs to carry. For example, in our very first line here, 240 volt electric furnace, we're carrying 60 amps. And so we have to have a larger diameter wire. So the smaller the number, the bigger the diameter of wire. So in this case, they're using 6-gauge wire. Common in our industry, we're in that 12 to 14 range for our 120 volt receptacles. So our power going to, let's say, our refrigerator is on a 20 amp circuit. They're using 12-gauge wire. Our lights and our electrical outlets, they're using 14-gauge wire. Our air conditioning units, 10-gauge wire. And then when we get into our secondary forms of electricity down here at the very bottom, our thermostat wire is usually 18-gauge, and it'll be either 18.2, 18.4, 18.5. That second number, 18 is the gauge, 2, 4, 5, 8 tells me how many wires of that are in that set of Romex. So 18.5 tells me there's 5 wires of 18 gauge, and they'll be color coded, and we'll talk about that as we get into heating and cooling. Most common here in the red section, 10, 12, and 14 in our property management. Different types of cables. We got Romex cable, BX cable. Wire is labeled by the number of conductors and if ground is present. So in this case, 12-2G tells me there's 2 12-gauge wires plus a ground. So in that amount, in that Romex, I've got 2 12-gauge, usually black and white, and I also have a ground in there. 14.3 shows me there's 14-gauge wire, 3 of them conductors, but there is no ground. Usually if there's 3 wires in there, though, you can get one of them be ground. Wiring devices. If we look here at our electrical outlet, what's wrong with this picture?
Neutrals are touching?
Does that matter?
Not really.
No, that doesn't matter. Anybody else see anything wrong here?
I don't know if this is the correct answer, but whenever I tighten them around the screws, I make sure they face both the same way and face the way as you're tightening down, so they kind of set firmer in the screw. But
that is the right answer. Yeah. So when we hooking up the wires here, if you look at the 2 screws, the one on the right, that wire is looped in the direction of tightening. The one to the left is not. So when we tighten that down, that actually will push that wire out. It doesn't make a solid connection. Wires should always be looped around that screw in the direction of tightening. And if we can see here, that's the one that's not. Circuit breaker panels. Now I know, because you guys are the best, that every property that you guys work at, every electrical box is clean and organized and looks just like this one, right? No, nothing. Yeah, not the case. This one's a very well organized, brand new circuit panel. The ones we deal with do not look like that. They're always painted over. Rat's nest of wiring. Oh, there's some things we could take away from here. We've got some single pole 20s and 15 amp breakers here that would deal with our lighting, our electrical outlets, our GFIs. If you notice here, top left, second one down, we've got a double pull breaker. So that's more than likely a 220 volt circuit, whether that be to the electrical oven and stove or outside to our air conditioner or to a dryer, clothes dryer. We got a bank of neutrals and grounds and power in and power out, with our main being up at the top left, very top here. If we were going to test this to know if our breaker panel has what it needs, where would we test it at? So if I'm walking up, go ahead.
I was gonna say for volts at the 2 leads with the red and the black wire, I guess it's a 4-gauge wire.
Yeah, you're right. So when you walk in, you're looking at this panel. I'm taking my leads and I'm putting my voltmeter on, and there's a setting for like 200 amp or 200 volts or 600 volts. I usually put mine at 600 volts because we're dealing with a little bit higher voltages here. And I put one of my leads on that top right red and my top left black. It doesn't matter which black and red on my meter goes there. It doesn't in this case. And I get a reading. And if it tells me I have 220 volts or 240 volts, then I know I have two separate legs of 120 volts. However, there are times where one of our legs drops out or goes bad. And so how could I test that? Well, I would go from the black on the top left to a ground. And if that told me 120 volts, then I'd move over to the red. If that one told me 0, then I would know that leg coming in to my breaker box is bad. Again, I'll be into there in December. We'll do some testing on some things over there that we can find a breaker box to run into. Circuit panel. The back of the circuit panel where the breaker hooks up is very brand specific. If we're going to replace a breaker in this panel, and this is a square D panel for a say, I need to put a square D breaker back in here. I can't go get a GE breaker or a Simmons breaker. Breakers are very brand specific. So if it's a square D, it needs a square D. Now there's some differences in square D and by the way they hook up in the back. So each one is specific to the breaker box you have. In this case, the feet if you look here on the far right where this bank of screws, the silver section, just to the left of that, there's like 4 black notches, and the feet of our breaker will actually tuck in there, and then they'll snap on or clip on to the metal section here in the middle to allow that breaker to connect. Like so. So what does a fuse or a breaker protect?
The circuit.
Okay.
The appliance to which it's servicing.
Okay. Anybody else?
Protects from a short circuit.
A short circuit. What does it protect overall?
The overall electrical system.
A conductor.
It protects the wire. And what does it protect the wire from? Well, by having that breaker on there, it's limiting the amount of amps that can go through that wire. You know, if we look back on our chart here, and it says 12 gauge, 20 amps is our max for 12 gauge. Well, if I didn't have that breaker on there and I decided to run 60 amps through that 12 gauge wire, what's going to happen to that wire?
Melt.
It's going to start on fire. Yeah, it's going to start on fire. And so that breaker is limiting the amount of amps I can have go through that wire and protecting that wire from starting on fire. So at the end of the day, especially for your test, and I should bang on some because it'll be on your test, what does a fuse or a breaker protect? It protects the wire. If the wire carries too much amperage, it will cause a fire. So it does protect the other things, but bottom line, air nuts protects the wire, because without the wire, none of the other things work. None of the other things are possible. Any questions on that? Not a very good not very good at checking chats. So if I pause and you see me looking up at my screen, it's because I'm checking chat. I'm not the best at that. I'm working on that. So next question, is a breaker a switch?
Yes. No, not something that you manually do. But
Okay.
it switches off by itself, I guess.
Kind of a trick question, isn't it?
Yeah.
You can switch it on and off. At the end of the day, a breaker is not a switch. A breaker is a device that's used to protect a circuit from overload. Your switch on the wall here is a switch, but can't, if it overamps, it's not going to pop into a neutral position to prevent current from flowing through it, right? That breaker will. So that breaker is not a switch. It's actually a safety. It's a device used to protect a circuit from overload. Again, this will be on your test. What's the purpose of a switch?
Open and close circuits.
Yeah. To make or break the flow of electricity or current, to turn on and turn off our light by stopping power or starting the power to that electrical appliance, to that light, to that vacuum, whatever it may be. So if we look here, I'm very high tech. We're very high tech here at the National Apartment Association with our slides. But you can look here, we've got our breaker feeding 110 volt power to our switch. And that switch breaks the power from one side to the other to our light. And then from our light, we have a neutral coming back to our panel. So as this sits right here, right now, if I were to put my leads on my two terminals on my switch, how many volts would I get?
0.
120.
120. Yeah, because there is a difference. At this point, my line coming from my breaker is my 120 volts, but my switch is open. So the bottom part of my switch right now is nothing. It's neutral. So I should have 120 volts. We'll get to that in another second here. So if I turn that switch on, look how that lights up. See, that's pretty high tech. So when I close that switch or open that switch, it feeds me power. What can I test? What can I use to test this switch to tell me if it's bad or good? Say again?
Continuity.
Continuity. Yeah, easy peasy. If I put my leads here and I have it set on continuity, am I going to have continuity right now? No. Yes. No beep. Beep. Very easy. So if we looked here, this is the question I just gave you between our power going in and our neutral. How many volts are we going to have?
0.
We'll have 120 there.
120 volts. Yeah, because that switch is open. So it's acted, that black line feeding back to the bottom of the switch is still on our neutral side because we're not making that connection. And if I test it here, I'm going to get the same thing, another 120 volts because that line is open. Now, if I make this switch, what am I going to get here now?
240?
No.
It gets 0 there because you're testing basically the same. You're basically
So this, whoever said 220, let me just say this. So this is just 120 volt circuit. And the way we can tell that in this schematic, for example, is that we have a neutral line. If we had a 220 volt line, it would say breaker on, and this neutral would also say line. So we'd have two lines. So it's never going to go to change from 120 to 240 in this scenario. So in this case, our two options are 120 volts or 0 volts. And our meter, if we remember back to the beginning of our teaching today, reads the difference. And so right now with our switch closed, there is no difference between the black line coming into our switch and the black line leaving our switch because it's all the same 120 volts. And so as it sits right now, because there's no difference, we're going to read 0. Does that make sense?
Yeah.
At this point,
you see now?
Yep.
We're removing the circuit wires from the switch. The end of the wires have some corrosion. At this point, we'll remove the corrosion by cutting the end of the wire and restripping it for a brand new connection. Utilizing a utility tool. Remove approximately 3/4 of an inch from insulation from the wire. This allows for wire to make full contact with the screws on the switch. Reconnecting the wires circuit to the switch. When reattaching the wires, make sure they are snug, not over tightened, and not loose. Need to be snug. Reconnect the ground wire. My scissors back in the wall. Switch is secured to the box. Place the switch plate. Once all the screws are snug, go to the breaker box, remove the lockout tagout kit, and line up.
Anything did wrong there?
Face shield, but no gloves.
Face shield, but no gloves. That's good. Anything else?
He didn't verify which one was hot.
Didn't verify which one was hot. Okay.
It looked like he screwed the wire in the opposite way.
It looked like in that case, I don't think he did. I think he even talked about going the direction of tightening, but right at the very end, I don't know if you caught it or not, but when he put that faceplate on, he tightened it too tight and cracked that faceplate. I don't know if you heard that. All right, let's see here.
I've never done that before.
I've done that so many times. I like the new ones now. They're a little more pliable. You can go a little further with them.
I'm not sure if you saw it, Brian, but Candy's asking why make a new end versus sanding the wire end?
So it's so much easier for me to cut the wire off, strip it, and re-bend it than it is to try to get a little sandpaper on the end of that wire, especially if there's enough wire in the box to make that new connection. If there's not enough wire in the box, then maybe you could go about doing it that way, but it's not very often we sand wire. It's usually just cut it off, strip it back, and usually strip it back about 3/4 of an inch. That's the trick and makes that connection new. Hope that answers your question.
We received a call for residents stating that they're.
Can you guys see that screen?
Yeah.
The dining room light fixture is not working, so we're going to go ahead and send a technician out there to diagnose the problem. Our technician is going to troubleshoot the call for the dining room not working, dining room light not working. Our technicians go ahead and remove the cover plate. Go ahead and take off the switch, removing the 2 screws. Please keep in mind that this still got power to it. Our technician is now going to do a test with his multimeter. We have power coming to the switch. Flip the switch. But we show no power going to the light fixture. So that determines that the switch is bad. So what we're going to do is we're going to go to the breaker panel and do a lockout tag out on that breaker. Our technician now is at our service panel, and he identified what breaker it was, and he's going ahead and turn it off. And he's going ahead and put a lockout tag out for that circuit. The technician's now going to check to make sure we don't have power to switch. And determine we don't, so we'll go ahead and replace this bad switch. Technician now is going to go ahead and remove the bad switch, removing 1 hole. And then the other pole coming in. And then the ground wire. Okay, technician is now going to install the new light switch. He's going ahead and connect 1 wire to the 1 set screw, making sure that the screw is tightly. And then the second wire to the set screw. Also make sure you torque down, make sure it's good and tight. Also make sure the loop is going in the direction of the set screw that it turns. That way it's tight and the screw doesn't unwind. Now he's doing the ground. Follow the same steps. Make sure it's good and tight. Okay, technicians are now going ahead and put the switch back into the wall. Making sure that the wires are going in there straight and not binding in any way. Go ahead and he tightens up 1 screw. Keep in mind not to over tighten. And then the bottom screw to the switch. Our technician has now replaced the switch, and we've removed the lockout tag out, and that's how you replace a bad switch.
Any questions on what he did there? All right, we've gone for another hour. It is was it after 10 there. Let's take 10 minutes. We'll start back about 10:20. Use the restroom, do what you need to do. All right, for those that are back, let's see, unmute. Okay. We're going to do skill checks 15 through 27. 15 through 27. So if you want to start on those, 15 through 27 on the skill check. All right, let's go through them. If you don't have them quite finished, fill them in as we go. Lexi, you want to start? Lex, you want to start with number 15?
What is the purpose of the black wire? The hot wire carries power through the circuit.
Yeah, it's the hot wire or the line. Eric, number 16. I love your view in the background, by the way. That's amazing.
Yeah, I figured I'd go with the fall theme.
I like it.
What is the purpose of the white wire? It's the neutral wire, and it's the return path of the circuit.
Yeah, return path, it's neutral or the common. Micah, 17.
That is the ground wire, or the green or the bare wire.
Yeah, it's ground. It's the ground wire. 18, Nathan.
What type of ladder is recommended for electrical work? Fiberglass.
Fiberglass. 19, Farshad. Farshad, you're gonna have to unmute yourself.
I'm sorry.
No worries. It's a new process for all of us.
Right. What type of tool is recommended to remove plastic insulation from wires? Is wire tools or pliers?
Wire tools or cable ripper. Remember that cable ripper we used for the row, we showed for the Romex. Jeremy, 20.
What is purpose of having well-insulated handles on electrical tools? Protect from electrical shock.
Yeah, protect from electrical shock. Protect you from, so you can keep all your fingers, all your toes walking upright. 21, Candace.
What is the purpose of using electrical test tools? Is to verify there's no power.
Yeah, verify. That's our V word for this class, and to verify that we're going to use our work on something safely. Raphael, 23. 22.
What are some of the functions of an electrical testing meter? Ohm, continuity, and voltage readings?
Yeah. Amps can also be there. Ohms, resistance, continuity. Ben, 23. Ben's frozen. Hey, Gary.
What size of wire is recommended? 120 volt light fixtures and receptacles. And that's a number 14.
14 gauge wire. He's breaking up quite a bit. So 14 gauge wire for 23. Gary, 24.
For 30 amp 240 is the 10 gauge.
10 gauge wire, correct. 25, Sean.
Makes a breaker trip. Short circuit will make a breaker trip.
Yep. What else?
Oh, what else?
What else? What is that breaker doing for the wire? It's protecting it from what?
Overheating.
Overload.
It protects the wires from
Yeah,
burning.
protects the wires from overload, from too many amps. It's protecting it from overloading from too many amps. Next one, Victor. 26.
Now you got me a little nervous.
Don't be nervous. It's okay. Life ain't that serious. We're gonna have fun. Who cares?
What item does a breaker protect? The wire?
The wire. Well done, Victor. Nice. 27. Nice. Gotta unmute yourself, brother.
Yep. How do you reset a trip breaker? All the way off, then on.
Yeah, all the way off and on. The common mistake sometimes by our residents is just to flip it back to the on position, and it'll never reset. So we got to turn it all the way off and then turn it back on. 28. 80. Oh, we stopped at 20. Never mind. I screwed up there. We're good. Let's move on. We're good.
Hey, Brian, Josh has a question. Will we learn more about tone and probe meters in this class?
Will we learn about Tone and probe meters. No, we will not. It's not something that's in this CAMT. I would say to reach our Google, maybe some classes at like a community college or something nearby that might have some of that in there, but we don't do a whole lot with the tone and probe. All right, three-way switches. I'm sure most of you have three-way switches on your property by a show of hands. How many of you guys have three-way switches? Yeah, quite a few of us. And what is the purpose of a three-way switch? It is used to control one device from multiple locations. So top and bottom of a stairway or ends of the hallway. When we look at our three-way switch here, we've got a couple things. First and foremost that we need to see is the travelers. And the travelers is what allows our power to go from one source to the next or one switch to the next. We have a ground wire on the bottom left because all of our circuits should be grounded. The often mistake here is our bottom right-hand one. And this one says common. And common, when we talk about voltages, is usually referred to as our neutral. But in this case, common is different. It's not really common. It's completer of the circuit. And in this case, our power wire, and I'll show you, we'll see this in a video, but our power wire is what's going to go to our common because it's going to complete the circuit. So our 120 volts or 110 volts is going to go to that antique brass or black looking screw from there on this one. And on the other side of our other switch, the same thing, our common here, or our completer of the circuit, our power in. And then the travelers are going to go from one switch to the next and feed power to our light. We'll watch this video and it'll help you understand the way this works. And when I come to see you guys, I'm going to bring some three-way switches and some wiring with us, and we're going to work on showing you how to wire those and how to test those. The one mistake that people often make is we all get critical about, oh man, if I wire this wrong, it reminds me of Victor a minute ago. You make me so nervous. You make me so nervous that if I wire this wrong, I'm going to blow this house up. But what's going to happen is if you wire it wrong, one switch is going to work and one switch is not going to work, and that's it. If you've got maybe things touching, it could happen where that breaker trips, but at the end of the day, nothing's going to blow up. It's not like a stopwatch is counting down and, oh my God, if I don't get this right, we're going to all blow up. It's just not going to work right. And so watch this video on three-way switches, and hopefully it'll help you give you more of an understanding of how to troubleshoot it, because I think there's been a disconnect for some years, and I struggled with it early in my maintenance career, and I've learned now it's very simple. I'm not blowing anything up. I'm not starting anything on fire. It's just not going to work right. So let's see if I can get this to get us here.
What we have here is a situation that's typically found in apartments. We have a three-way switch circuit, which includes two switch boxes and our light fixture.
I see the video.
As you know, a three-way switch gives us the opportunity.
Can you see it now?
Yeah, sorry.
You need to control one fixture from two different. What we have here is a situation that's typically found in apartments. We have a three-way switch circuit, which includes two switch boxes and our light fixture. As you know, a three-way switch gives us the opportunity to control one fixture from two different locations. What happens often is that for whatever reason, both switches are removed so that a technician just has two boxes open with wires sticking out. The goal of this video is to show how to properly connect a three-way switch circuit by using your meter and determining what the proper connections are. The first step is to take the leads of our meter and determine which wire has power coming from the breaker. In order to do this, we have to turn the power on and safely take one lead and connect it to the grounding wire. And the other lead, we look for voltage in between these wires. Once I've determined that this wire is the live wire, again, I go back to the breaker box, and this time I need to turn the breaker off and use lockout tagout equipment. Since the power is removed and I've determined that this is the hot wire, for right now, I'm just going to bend it up out of the way, keep it identified. I now have two other wires coming out of my first box. And in this case, I have three wires that come out of the second box. What I need to do is determine which two wires in the second box are connected to this one. So what I'm going to do is actually take a wire nut and connect these two wires together. Remember, the power is turned off and I've locked out, tagged out the circuit and verified that there is no voltage going through these wires. The next step is, since we've got that first box, two wires connected, I'm going to take my meter and change it to the continuity setting. Where when I'm testing for continuity, what I'm looking for is an electrical connection between any two of these wires. So what I do is I pick any two of the wires and test it. In between these two, I do not have continuity. And yet when I move to this one, I do. What that tells me is that this red wire and this black wire are the runners in between the two boxes. Now I know how to connect my switches up. On the back of a three-way switch, we have three terminals. Two of those terminals will be regular brass colored. The third terminal is almost black, or it's called antique brass is the color that it is associated with. One that is almost brass, if you're able to see on here in very, very small type, it's identified as the common terminal. Common just means completer of the circuit. These two wires here that I've identified as having continuity are the two wires that connect to the other two terminals. Those terminals are called travelers. In our second box, we only have one wire left, to where this wire will end up being, in this case, a black wire, and that black wire is the wire that carries power to our light fixture. That final black wire is what will connect to the common terminal on our three-way switch. Notice that when making connection to threaded terminals, the wire goes around the threaded terminal in the direction of tightening. Once we're finished making those connections, we can turn the power back on and check it.
Does that simplify things up when working with three-way switches? Does that make things easier the way he did it?
Yeah. So in this case with the three-way switch, they call this common, which in my case, when I learned it, we would call it the end of the line, where the circuit stops. Well, not the circuit, but where it stops. But here they call it the common.
Yeah, and if you notice, if you look on the back of these switches when you buy them, it actually says common on the plastic right behind there. And it's really not common though. It's the completer of the circuit or the end of the line in your case. And you're right. I think that's named poorly, but now that we've exposed it and we all know now that, oh, it's the completer of the circuit or the end of the line where we're going to send our power to, I think it makes things easier in figuring out from one box to the other. So if I was at top and bottom of a hallway, I can identify the common and then shut the power off and put those two wires together that are left and determine which two of those are down on the bottom end of the stairs and figure out, oh, okay, those are my travelers, which leaves this last one as my power. It makes things very simple. Sometimes we get overwhelmed in our own brains and overthink things, but it's pretty simple when we start thinking about it. Any questions on that three-way switch? And then basically the way it works, if we look at it here, we've got our common, which is our power coming in, and we're just transferring it from one traveler to the next to send power to our light or not to our light. In this case, this is how it would hook up. We'll review this slide again when I come and see you here in December so that we can learn to wire them there. But if you look here and we make a switch, we turn the light on. We shut the other switch off, it turns the light off. Any questions on three-way switches? Check my chats because I struggle with that again. Oh, chats, okay. All right, receptacles allows to safely extend a circuit. Polarized, the neutral terminal is the wider terminal. And if we look here, we've got a couple ways to hook it up. And our brass colored ones on our outlets are always going to be our hot side. It's always going to be our power in. So brass is always our power in. The silver side is always our neutral. And on this case, we are, oh, look at that. I had a check come in. All right. So if we look on we can hook to our wires to the neutral side and our hot side via the screws, or they give us an option here to plug the wire into the back of the receptacle with the bottom square being our release. So if we pressed in the wire into the back of the receptacle here, in order to release it, we'd have to take a small thermostat screwdriver into the square there, and that would release the wire. I have issues with the plug-in type on the back of these, especially, I don't know, maybe Candace can tell us her opinion on them, but on some new construction, I've had it where those wires have popped out and have not made a good solid connection. Have you had any issues with that, Candace, on your new properties?
Some, a little bit, where they do pop out, or just the opposite, where when you go to release them, it's very difficult to get the wire out without cutting it off.
Yeah, correct. And so I'm old. I don't want to say I'm old school because it makes me feel old, and I'm not really all that old yet. But I really like the connections on the screws. One, I can determine how my wire sets by looping it in the direction of tightening, and I actually pinch mine a little bit around that screw, so I'm making a good connection. I know by tightening that screw that I'm getting a good solid connection to that wire. And then if I ever have to release it, I can undo the screw and undo that thing very easily. So if you ever have the option to choose between the two, please defer to the screw side of it and hooking the wire up that way than the plug-in terminal. I know they try to make things quicker for the electricians, and it really does, I think, create more of a headache, because if one of those connections come loose in the wall and there's more than just that, usually there's more than just this one outlet on that circuit, and then you're having to try to figure out which one that is and going back, and it's a whole mess. If you're going to do it the easy way for you, and I think it's the right way, and it's hook it to the screws. If we look here too on this outlet, we can see a bar that goes between the two screws on either side. What is that bar for? Anybody know?
Jumper?
It is.
Jumper?
Yeah, it is a jumper. What happens if we break one of these?
You can connect the light switch to it.
Yeah, so if we break, those are there so that if you can wire them directly, so like this way, it's going to be top and bottom. The plug-in works no matter what. You can also break them in the between. There's a break tab on there that we can break off and make this one bottom outlet work with a switch. And so if you see them, I made a mistake once. The owner of our company had me go rewire all the outlets in his house from the regular ones to square ones. I didn't pay attention that some of those bars were broken, and so things weren't working. I was like, oh, geez Louise. So pay attention, because if you're taking one out and it's got that tab broke, you'll need to put it back with the tab broke so the switch that operates it works for the next resident. We broke that one side here, so it's allowed a switch to change. All right, changing the receptacle.
We received a call from a resident saying that the electrical outlet in the living room is not working, and we're going to go check the outlet.
Everybody can see that screen?
Is that to make sure that the power is off to the outlet. He's checking the with the meter, and there's no power on the outlet. He's now going to pull the outlet out for inspection, and he's going to check it for continuity. He's going to use his multimeter and check the outlet to find out what the problem is. He checks the neutral, he checks the black bars coming in, and he finds no continuity on the black wire. So determined that there is a short in the outlet and it needs to be replaced. He's now pulling the wires off the damaged outlet. He's taking the black wires off the terminals. He's now removing the neutrals and the ground. And he's going to remove the outlet and install the new one. Making sure all the wires are solid and that they are going in the same direction as the terminal. Got the new outlet. He's going to install the black wires in the hot side of the outlet. Notice that he's putting the wires in the same direction as the screw. And he's making tight connections. Bringing the neutral wire around. And installing that on the neutral side of the outlet. You want to make sure that the neutral wires are on the neutral side of the outlet and the hot wires are on the hot side of the outlet to avoid reversing the polarity. He's attaching the ground wire to the ground terminal. Making sure that all the connections are tight. He's gonna put the outlet back in the wall, very careful. And he's going to center the outlet in the electrical box. I want to make sure that the outlet is in the center of the box to avoid the connections in contact with the box. Now it is not in the box secured, and he's going to install the cover plate and secure it with the center screw.
Now we have replaced the outlet, and we're going to test it and make sure that it's working by using this tool. And two of the lights are on, and that means that it's correct and that it's working.
Okay, any questions on that? All right, GFCI, ground fault circuit interrupted. Protects the user, it's near water, can be installed in series. What does that mean, installed in series?
You can have more than one receptacle controlled by the single GFCI.
Yeah, it's like a string of Christmas lights. If I have this at one section and I still have electrical outlets down the line, this would protect those other outlets, just like on a set of Christmas lights. If one light bulb goes, sometimes they all go. This is the same thing. If we'll get water by one of those outlets, this GFCI would still protect it. How do we test a GFCI?
With the test and reset button?
Correct. So if we hit test and reset, what happens if it doesn't reset?
And it's bad.
It's bad. Or be another reason it doesn't reset.
Lack of power.
Lack of power. Yeah. So that's the two things to troubleshoot it. If it's not working, we test it, won't reset. Let's check to make sure we have power. If we have power, then it tells us that GFCI is bad. Incandescent light fixtures. We've talked about this before. We're making sure we use that ground wire. Pretty simple though, 2 wires, power in has to equal power out. I'm not going to show you. Let's see.
It's not working, and we're going to go and assess the problem.
We are now at the apartment, and we're going to check the light switch to the closet light to see if it's working properly. He's removing the cover plate. And he's going to take the switch out of the wall for inspection. You take the switch out of the wall, and he's going to check for continuity on the switch. Turn it on. And he has continuity on the switch. And that means the switch is working. So he's going to put the switch back in the wall.
Continuity.
Make sure that the switch is in the center of the electrical box.
So now what we're going to do is we're going to go to the breaker panel and do a lockout tag out on that breaker. Our technician now is at our service panel, and he identified what breaker it was, and he's going ahead and turn it off. He's going ahead and put a lockout tag out for that circuit.
We're now in the closet and we're gonna check the light fixture and find out what the problem is. Technician is removing the glass cover from the fixture. He's going to remove the light bulb. And he's taking the light fixture down for inspection. He's loosened the two screws that are holding the fixture in the electrical box and pulling the light fixture down. He's going to inspect the light fixture now and find out what the problem might be. He's checking the connections and making sure the connections are right. Taking the light fixture off the wiring and inspect the light fixture itself. The technician is going to check the light fixture now. He's taking the black wire coming into the light fixture and the center of the socket for continuity. He doesn't get any continuity, and there's a short inside the light fixture. The light fixture needs to be replaced. The technician is now going to install the new light fixture. He's connecting the hot wire on the line coming in with the black wire on the light fixture. In the neutral white to neutral white on the light fixture. Make sure the connections are tight. He's now connecting the ground wire to the ground on the light fixture. Make sure the light fixture is grounded. Now all the connections are tight. He's putting back in the box carefully. And he's putting the light fixture back in place. Now tighten the screws to secure the light fixture to the electrical box. Now put the light bulb back on. Make sure that use a new light bulb every time you replace the light fixture. And now he's going to put the light cover on. Secure it.
We're going to test the light and make sure that it's working. And the light came on, turn it off. So we have completed the job.
Okay, so we're going to talk. This one's going to be how to change the ballast in a fluorescent light. It's the last video we have on our series today.
The first step is to remove the diffuser. Second step is to remove the light bulbs from their sockets. And he wants to inspect each of the sockets to make sure there's no damage or corrosion. Remove the ballast cover panel. And that will expose the ballast and the wiring associated. The next step is to cut the appropriate wires and remove the ballast. This is after the power has been secured properly using lockout tagout. Now the wires have been cut. The screws on each end will be removed to allow us to replace the ballast. The old ballast is removed. New ballast is now ready to be installed. Ballast is secured. Each of the wires will need to be stripped to allow a 1/2 to 3/4 of an inch of exposed wire for proper connection. The wires are stripped. Now he will reattach wires matching colors. Wires will be screwed together and secured using wire nuts. As the wires are connected, they're bunched together properly to allow clearance of the ballast cover to be reinstalled. Now the incoming power wires will be reattached. All connections are tight and secured. The ballast cover will now be replaced. When replacing the ballast cover, make sure the wires are exposed under the cover. Ballast cover is in place, replace the light bulbs. Light bulbs are replaced. Now replace the diffuser. When it's replaced, you go to the curtain box, remove the lockout tagout device, and return the power on. Now the switch is turned on.
All right. So what are some things that he did wrong there or could have done better?
Should have undone that rat's nest of wires up there.
Cut the wires a lot shorter.
Absolutely. Yeah, he could have cut those wires a little shorter, put them together a little nicer, maybe wire tied them or a little electrical tape that up instead of just bunching them together in a group like that. What else did you notice in that video?
He didn't verify the power was off.
Didn't verify power was off. Was he wearing any PPEs?
No.
Just his glasses. Did he replace the bulbs and new bulbs?
Don't know.
You can still see the black ends on both of those bulbs. So I think those were the same exact bulbs that they started with. So a couple things to notice. If you get a chance, then you're going to replace one of these. Obviously now things are changing. If you can replace them with LEDs, that's the way to go. If you have to change those though, and then you have T12s, go to T8s. Shorten those wires up so they're not so bunched up that you get them caught underneath the cover. Those diffusers, they get brittle and cracked. So if you're going to take those off, go real easy with them because more than likely you can break those. Any questions up to now?
Yeah. If one of those bulbs goes out, does that weaken the ballast or make it go bad faster?
I don't know exactly for sure. I would say yes, it could happen, but just like with all things, you want it to run the way it was intended to run with 2 bulbs or 4 bulbs, depending on that fixture. And anything other than that, if it's not running right, can take away from it and cause more wear and tear.
Right. One other thing to note is on the newer fixtures, there is a clip on the power wires. So you can just unclip it and there's never the exposed power wires.
Correct, which is nice. Yeah, they're like a Molex plug, right?
Yeah.
Yeah, I like those a lot better as well. All right, let's take 10 minutes. We've gone for another hour. It's 11:15 your time. So let's start back about 11:25. Use the restroom and we'll finish up for the day. All right, if you're not done with them, we'll just fill them in as we go. 28, Nick. Nick, you got to unmute yourself, buddy. There you go.
What could be the problem if the breaker trips when you turn a wall switch on, grounding out, short circuit in the line?
Yeah, short circuited, grounded. 29, Paul.
What is a 3-way switch? Control the multiple devices?
Yeah, 2 switches that control one device from either in the hallway or up and down the stairs. 30, Yimmy. Gotta unmute yourself, Yimmy.
story, I think, is the voltage.
Says, what is the small slot in the electrical side? Yeah, voltage or hot wire.
Yep.
Good. 31, Mosen.
Okay, what could be the problem in a rectangle that feels warm? Maybe warm?
Anybody have anything different?
I would say an
Maybe
open
overloading.
Overload. Yeah, too much amp. Over amping, or a loose connection maybe. Next one, Carlos. 32. Carlos, can you hear me? Okay, Eric, 32.
What are the parts of a fluorescent light fixture? Ballast cover, bulbs, sockets, and cover.
Good. 33, Bryce.
What could be the problem with a fluorescent light fixture that is flickering, either the bulb itself or the ballast?
Bad ballast, bad bulb, or maybe a bad socket if it's given it a loose connection.
Like a bad tombstone?
Yes, yes, correct. Aiden, 34.
What could be the problem in a smoke detector that does not sound when the bottom is pushed? Bad smoke detector or dead battery?
Yeah, bad smoke detector, bad battery, or no voltage. Some of them are hardwired, so no voltage. 35, Victor. Don't be nervous.
That's the only one I didn't answer.
Okay, that's fine. I knew you knew I was going to pick on you too. He's like,
I said the other ones. I had them already, but this is the one I said. I didn't.
What
answer.
should be used to test the full function of smoke detector? We didn't talk about it yet, but can smoke. Shoot that smoke at it, and it should, alert the smoke.
That's what I thought.
You would have been right. All right.
On the fire on it.
Yeah, just start a fire underneath, smoke cigarette, whatever. All right, compact fluorescent lights. These are kind of a thing of the past. Some of these slides are outdated. I'm hoping that they update the CAMT. We're into LEDs now, but for the purpose of this, a 60-watt bulb is 15 watts. So our 60-watt incandescent, this same bulb only uses 15 watts of power, but gives them the same amount of light. Some things to take into note if you have some of these on your property. Can you just throw them in the trash?
No.
Why? Why, Victor?
For what they have, they need to recycle.
Recycle. What's inside of them? Anybody know?
Mercury.
Mercury, yeah, and mercury is a hazardous waste, so we can't just go throwing those away. Same with our fluorescent bulbs. Many contain mercury. Beware of your local codes for proper disposal. I know here where I'm at, we take them to Lowe's or Home Depot, and they can get rid of them for us. And in many areas, it's illegal to throw these bulbs away because of the mercury. Smoke and carbon monoxide. Carbon monoxide, we're going to talk a lot about when we get into gas-fired furnaces, but it is a tasteless, odorless, invisible poison, deadly at high concentrations, and if you have low concentration of it, it can compound some health conditions. Commonly misdiagnosed as flu-like symptoms. Lower chronic exposure to carbon monoxide may not be diagnosed, but head stuffiness, sinus pressure, and headaches may be symptoms of it. The reason we're talking about this because a lot of our smoke detectors now are smoke detector and carbon monoxide detectors all in one. I know here where I'm at in Omaha, Nebraska, our code now is that there's a gas-fired furnace in the residence, that there needs to be a carbon monoxide detector in the home itself, also in the exterior hallway. Also, if there's a garage attached where cars come in, we have to have a carbon monoxide detector as well. don't know what it's there. But again, we'll talk more about carbon monoxide when we get into gas-fired appliances. And if we look here, our wiring for our alarms for these, we have a power in, our hot wire, which is black, our neutral, which is our white wire, and then red, which is a traveler. And what does that traveler do? It allows all the alarms to sound at once if one alarm sounds. So if this first one on the left senses there's a fire, it'll send signal to all the other smoke detectors on that are wired in series with this to turn on to get everybody the heck out of there. Any questions?
I have more of a test prep question.
Okay.
On the gauge of the wiring, the amperage, do you think, or do you know if that is going to be something on the test that people should focus on versus, 10 gauge needing 30 amps, 14?
All right, so to be completely honest, for a small fee, I have all the answers to the test. I'm just kidding. I do have the answers, but I'm not selling them. I was one of the few that helped write the test. There is no question that I can recall on there in regards to amperage and wire size. Josh says, while working at a complex in Snohomish County, another maintenance supervisor mentioned that he got a code violation for using the quick connection on the outlets. Is there a way to verify this? I don't know. I would call the county there in Snohomish County and ask if that's against their code. Again, every city, every county has different code requirements. I know here in Omaha, we are heavily regulated code-wise from our city to do a lot of stupid things that most companies or most cities don't do across the United States. So everyone's a little different. If you have a question in regards to that particular county's code, I would call their permits and planning department and ask for one of their inspectors. And they usually aren't in the office all day. They're out, inspecting, but usually they'll call you back first thing in the morning. At least that's the way it is here, and answer your questions. Hopefully that helps you, Josh. Any other questions? See you guys tomorrow. Have a good night. Oh, chat. Yep, good. All right. Have a good night. See you guys tomorrow. Same bat time, same bat channel.
Thanks, Brian.
Thank you, sir.
Thanks, guys.
Thank you.
Thanks.
Yep.